Yeah. So this, in this case, the lithium lost one electron, chlorine gained one electron, and it was because in both cases they both wanted to have full outer shells. So the lithium had a very small number of electrons in the outer shell. It only had one. It was in group 1, so it made much more sense for it to lose an electron. And chlorine was in group 7, so it made much more sense for it to gain an electron. Okay, so chlorine would always form a Cl minus ion, and lithium would always form an Li plus ion because it's the easiest way for them to both produce full outer shells. Okay. Right. So in this case, this is ionic bonding. Okay. This is ionic bonding because they both bonded by producing. They both produced ions. Right. They oops. Oh. They both produced ions, so a positive and a negative ion, and then they basically became attracted to each other. So that's what ionic bonding is. And in general, a large majority of the time, the metals will form positive ions, and the non-metals will form negative ions because metals are on the left-hand side. They have a small group number, and so a small number of electrons in the outer shell, and so it's easier in general for electrons to produce positive ions. So ionic bonding is in general metal plus metal and non-metal. However, there are exceptions. Especially one of the exceptions that exist is NH4 positive ion there, and in fact H plus. And we sort of like get an inkling as to why that might be an exception, because a hydrogen, despite the fact it's a non-metal, is in group 1, right? So it's a weird one. So hydrogen actually forms positive ions, and NH4 plus is a ammonium ion. So you can have non-metal positive ions, but in general, it's a metal ion would be positive, non-metal would be negative. And what they do is they donate so the metal or the positive ion, well, the metal, let's say, would donate an electron to the non-metal ion, and then they would produce they would be attracted. Now, very important thing to realize about ionic bonding is that they do not form molecules. Don't let anybody tell you anything else. It's surprising how many times I hear experienced people say, just randomly throw about the word molecule when talking about ionic substances. It doesn't happen. You have ionic lattices, because when you think about it, we have a positive ion here, a negative ion here. Let's do that again, like that, right? And on the other side of the negative ion, it would still attract another positive ion, right? There's no reason why that would stop, right? And you could just keep adding these ions onto it, right? And so it forms a lattice. It's sort of a never-ending pattern. So that's what a lattice is, basically. A difference being with a molecule, let's take, and we haven't looked at covalent bonding yet, but covalent bonds, molecules are always made out of covalent bonds, not ionic bonds. We have something like, let's say, 2 hydrogen atoms. Oops. Without going into the details of covalent bonding, they are formed by sharing electrons. Okay, and together they make a pair, and that pair is a molecule, right? If I had another molecule of hydrogen, well, yeah, they do actually feel a slight attractive force, but nothing like the force that this negative ion feels towards this positive ion. So this is a very very weak force between them, whereas these have a very strong force, and that's why these ionic compounds have a high melting point or boiling point, because you have to actually rip these ions away from one another, whereas the covalent substances, they have a very low boiling point and low melting point because they don't have a very strong attractive force between the molecules. Okay.